Okay, and started for lesson 3. So differentiate the following: d by dx of 4 cos 5x. Well, cos goes to minus sine. I'll leave the 4 alone. And I also need times by, remember, derivative of that. So times by 5, which gives me minus 20 sine 5x. Okay, d by dx. Well, the next one is ln 6x plus 5. Remember, ln's 1 over, so 1 over 6x plus 5. I need times by the derivative of that, times by 6. So 6 over 6x plus 5. And then d by dx, the last one, is sine 5x. Well, for this one, you might actually want to write out the chain rule. So I call u sine x, then y is u5. So dy by du, so 5u4, and du by dx is cos x. So times them together, so I get 5 cos x times u4, and u was sine, so it's sine 4x. And you might be able to do that without writing the chain rule out, especially if you practice a lot. But if it helps to write the chain rule out, write it out. Remember, the chain rule is just dy by du times du by dx. Okay, next one. Fine, there we go, got it. So we have f of x is e to the 5x, g of x is e to the 10x. We want to see how can we get from this to this. Well, hopefully you can spot easily that g of x, if I change x into 2x, 5 times 2x is 10x, so just f of 2x. So just stretch in the x direction, and the scale factor goes the opposite, so it's a half. And again, you can use your calculator to check that. So sketch both graphs in the calculator, and you should be able to see it. Okay, next one, 3x minus 5 is 2x plus 1. So again, there's 2 ways to start this, but more than 2 ways, but 2 common ways. So you can change them into e's. So e to the x minus 5 ln 3 equals e to the 2x plus 1 ln 2. And you can do ln on both sides, which cancels out the e's. So x minus 5 ln 3 equals 2x plus 1 ln 2. The brackets are really important. The other way, which some of you might do, is we do ln on both sides. Then what can happen is the power can go to the front, and you get to this line without doing this step in the middle. Yeah, look, power's at the front, power's at the front. And then just expand the bracket. So x ln 3, take by 5 ln 3 is 2x ln 2 plus ln 2. All the x's on one side, so I want to take that to that side. So x ln 3 minus 2x ln 2 equals ln 2 plus that 5 ln 3. Factorize out the x. I said to factorize out the x, I just left one in. Very stupid. Then divide by that factor, so ln 2 plus 5 ln 3 over ln 3 minus 2 ln 2. Okay. Fourth one. The sequence starts 5, 7, and says 2 parts. Find sum of the first 10 terms if it's arithmetic. So if it's arithmetic, then A is 5, D is 2, it's going in 2s, and N is 10. So S10 is, use the formula from the formula booklet, N over 2, 2 times A, plus N minus 1 times D, and just type in a calculator. So 5 times 10, add 18, so 140. And if it's geometric, A is 5, R is 7 over 5, or you can write that as 1.4 if you prefer decimals. N is 10, then you again use the formula. So it's A, 1 minus R to the N, divided by 1 minus R. Now again, you can switch these around. You can have Rn minus 1 and R minus 1 at the bottom. So if I just type that in the calculator, 1 minus 1.4 to the power 10 over 1 minus 1.4. So we get 349.068. So that will be a fraction, an exact answer. However, it won't show up in the calculator because it's going to be too big. So instead, we just round it to 3 significant figures. So 349. Okay, and the last one, back to some mechanics. Find an expression distance between these two vectors. T4 and 5, T add 1. Oh, okay, so to do this, first of all, if I call that A, that B, to get A to B, remember it's OB minus OA. So I can do 5t plus 1, take away t4, which gives us 5 minus t and t minus 3. 1 take away 4 is 3. Then to get the distance, that's when we square root each term squared and add it together. So that, now let's just simplify that. So again, you can times these out this side, you can use the binomial quickly in your head. So 25 minus 5 times t times 2, so 10t plus t squared minus 6t plus 9, which gives us 2t squared minus 16t plus 34. Now, you could factorize that 2, but then you just have this at front, root 2 times that, which doesn't look any nicer. So I'll probably leave the 2 inside.